Sea level rise has been a persistent issue that began with the onset of the Industrial Revolution, characterized by significant increases in global temperatures due to anthropogenic greenhouse gas emissions. One of the earliest documented impacts can be traced back to the early 1800s, when scientists first started observing changes in sea levels through tide gauge measurements off the coast of England. These initial observations highlighted a gradual but noticeable rise over time, with some researchers estimating an increase of approximately 2 centimeters per decade during this period. As industrialization accelerated globally in subsequent decades, particularly in the mid-1900s, when fossil fuel combustion for energy production surged significantly, so too did sea level rise. This phenomenon was not solely localized. It affected coastal regions worldwide due to the nature of oceanic currents and geological formations. For instance, India's coastline has seen a steady increase in mean sea levels over recent years, with several studies indicating an average annual rise of around 3 millimeters since the mid-20th century. Several factors contribute to this ongoing trend, including thermal expansion of seawater as temperatures climb, melting glaciers and ice sheets, particularly from Antarctica and Greenland, and land subsidence due to human-induced processes such as groundwater extraction. These impacts are exacerbated by regional variations in sea level rise rates, with some areas experiencing more pronounced increases than others. The measurable effects of rising seas have been profound for coastal communities around the world. In India alone, over 13 million people live within 1 meter of current sea levels. Projections suggest that if climate change continues at its current pace, by mid-century up to 50% of these residents could be displaced due to inundation or erosion. Economically, significant damage is anticipated, with estimates suggesting potential annual economic losses amounting to several $billion globally for low-lying island nations and heavily populated coastal regions like India. While some argue that sea level rise serves as a stark reminder to reduce carbon emissions now before irreversible changes occur, others highlight the importance of adaptive strategies, such as building seawalls, elevating buildings, or relocating vulnerable populations. Mitigation efforts remain crucial in slowing further rise. However, adaptation will likely be an integral part of any long-term strategy. Looking towards the year 2050, scientists predict that under various climate scenarios ranging from business as usual to ambitious decarbonization pathways, global mean sea levels could rise by anywhere between 17 and 98 centimeters. This forecast underscores both the urgency for immediate action as well as the necessity for continued research into effective solutions. Incorporating innovative technologies like enhanced coastal defenses, improved early warning systems, and more sustainable urban planning could mitigate some of these effects while ensuring resilience for future generations.